This video is part of our upcoming course on modern C++, which is going to be using C++20 from the absolute beginning all the way to pretty advanced things. This is going to go from zero, and it is going to cover really advanced things like function templates, class templates, move semantics, function-like entities, and really all kinds of crazy things. On top of that, we're going to cover the 4 big features of C++20, and these are ranges, modules, coroutines, and concepts. And on top of that, we're going to cover the 3-way comparison operator and a bunch of other things we have in C++20 that you really are going to like. If you are an existing developer or if you are starting fresh, you're going to find something useful in this course. If you are interested, please check the link in the description below. You're going to find all the information on the course. Now, the topic of this video is implementing your own 3-way comparison operator, which is going to be doing custom comparisons. If you need a refresher, I have a full playlist on the 3-way comparison infrastructure we have in C++, and you're going to have a lot of information on this. So if you get confused somewhere in this video, this playlist is probably going to be your best bet. In this lecture, we're going to see how we can set up a custom implementation of the 3-way comparison operator. And we might want to do this if we don't want to default member-wise lexicographical comparison we get if we default the 3-way comparison operator. And the syntax to set it up without defaulting it is really simple. You specify the return type, you say the operator you are overloading, and then you pass your second parameter, which is going to be our second operand to this 3-way comparison operator. We also mark it as const because we don't intend for this to modify our member variables. And this is really it. Once you have this in, you can put in an implementation, and the compiler is going to pick this up and use it to do comparisons. The same benefits we had with the default implementation of this operator are also going to be applying. For example, the compiler is going to use this to generate our greater than and less than versions of our comparisons. But one thing we want to get is the equals operator. Because we have said that we want to put in our own implementation of the operator here, the compiler knows that whatever it might come up with by default might be wrong. So the responsibility to put in the equals operator falls on you if you put in your own custom implementation for the 3-way comparison operator. So once we have this set up, we can put in our implementation. In our point implementation, we want to compare points based on the length or the distance from the origin point. Again, if we consider a Cartesian coordinate system, we have an x-axis, which is horizontal. We have a y-axis, which is vertical. If we have a point here, for example, it is going to be less than a point whose distance is further away from the origin point. So this point is going to be greater than the point we have here. And this is the relationship we want to set up here and use the 3-way comparison operator to help us generate all the other operators. Here is our implementation of the 3-way comparison operator. We are going to return partial ordering because we are working on double member variables, and the double type by default supports partial ordering. So that's why we are returning partial ordering here, because it is possible to compare 2 double values, and one of them might be an incomparable value that we can't compare to other double values. That's why we are returning std partial ordering here. The body of the function is really simple. We're going to test and see if the length for the left object is greater than the length for the right object. If that's the case, we're going to return std partial ordering greater, meaning that the left operand is greater than the right one. If the lengths are equal, we're going to say that they are equal. We're going to return std partial ordering equivalent. And if the left object, its length is less than the length of the right object, we're going to say that the object on the left is less than what we have to the right. And we're going to say that using std partial ordering less that we return from our function here. If neither of these things apply, we're going to note that one of the operands must be incomparable to others, and we're going to return std partial ordering unordered to mean that one of the operands is incomparable to other things, and we can't carry out the comparison here. This is what we mean when we return std partial ordering. If we go up, we're going to see that we have also set up our own equals operator. Again, if you put in your own implementation for the three-way comparison operator, the compiler is not going to generate an equals operator for you. You need to put that in yourself because you know how you want to compare these points. We want to compare based on length, so we're going to check and see if the length for the current object we are calling the operator on is equal to the length of the other object that we passed as a parameter here. And this is going to do our thing. Okay, once we have our operators in, we will be able to compare point objects. We can use the greater than operator, the greater than or equal operator, the equals operator, the not equals operator, the less than operator, and the less than or equals operator. All these things are going to work. Please note that this is also going to support implicit conversions. So if we pass things in an order that doesn't work by default, the compiler is free to flip things around until it finds an arrangement that is going to make things work, like we have seen for the other operators we have covered so far. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is custom spaceship operator for ordering. We are going to reuse the code for the custom equality operator we did because in there we have a point class that we can reuse. So we're going to grab the entire thing. We're going to copy the code and we're going to put that in our current project, I should say. And we're going to drag and drop this to open this up in Visual Studio Code. This is going to give us our project here. We have our point class. We have the header for that. We have the implementation file, which happens to have a commented out version of the not equals operator that we don't need. We can take this out because this is going to be generated by the compiler anyway, so we can take this out. It was in here for demonstration purposes only, but now we know this. We don't need that in here anymore. So you see we have an equals operator, but we're going to need this because we're going to do our own custom three-way comparison operator, and the compiler is not going to give us an equals operator. If we go in the implementation file, we're going to see that this is going to compare based on length, which is really what we want. So we can really set up our three-way comparison operator. But before we set it up, we need to make it super clear what we're going to be returning from that three-way comparison operator. The deciding factor here is the type that we have in our member variables. The type happens to be double, and a double by default supports partial ordering because it is possible to have incomparable values. So it makes sense to return that kind of ordering because we are going to be comparing doubles anyway. If you go in our length function, you're going to see that we're going to be returning double, and we are going to be comparing lengths to know which point is greater than the other. So we're going to be returning partial ordering here. You should know this. So what we're going to do, we're going to say std partial ordering because that's what we want. We're going to say operator, three-way comparison, that's what we want. And we're going to be comparing to another point object. We can say other, like we said for the equals operator, and we're going to make this a cast member function because we don't intend for this to modify our point object. It's not going to be modifying the member variables we have in here. Okay, now that we have this in place, we can copy the header for the file and go in our CPP file and put in the implementation. So we're going to paste the header in, and we're going to say that this is a member function for the point class, and we're going to put in a body. And we are going to compare things. We're going to be comparing the current object which we called our three-way comparison on, to the second parameter that is going to be our right operand to our three-way comparison operator. If the current object's length is greater than what we have to the right, I mean the length of that, we're going to know that this object is greater than the one we have in the parameter here. So we're going to return partial ordering greater. If we go back to the documentation at CPP reference for STD partial ordering, we're going to see that we have a bunch of possible values for this. We can have less, we can have equivalent, we can have greater, we can have unordered. And unordered is going to indicate relationship with an incomparable value. So this means that we are trying to compare to something we shouldn't really be comparing with. Okay, so these are our possible values here, and we're going to be using all these in our implementation of the three-way comparison operator. Okay, so if the current object is greater, we're going to return partial ordering greater. If the current object is equal to the right object, and by equal I mean their lengths, we're going to return STD partial ordering equivalent to mean that they are equivalent. And if the current object's length is less than that of the right object, we're going to say STD partial ordering less. That's what we're going to return. And if neither of these apply, we're going to say that we must be comparing to something we shouldn't really be comparing with. And we're going to return STD partial ordering unordered here. I don't know why we have this squiggly lines in. Maybe I messed something up on top here. Let's try and check. Sometimes Visual Studio Code messes things up. So let's close and open this again and see if the squiggly lines go away. Looks like we are fine. And we should call our other thing right here, because this is what the code I have in the body is saying. We can go in the header and change that, but that's not going to matter. You can have different names, but we're going to be consistent here and use right. Now we have our three-way comparison operator n, and we can use this to compare using all the greater than and less than versions of the operators. In the main function, we are only using the equals and not equals operators, but we can do better now. We can use the less than, the greater than, less than or equal, and greater than or equal, and these are going to work. Okay, so for example, if we take all this out and put in another piece of code which is going to reuse all these operators, we're going to see that this is going to work, and this is really cool. We can use greater than, we can use greater or equal, we can use equals equals because we have an equals operator. The compiler is going to use that equals operator and generate a not equals operator, and this is really cool. We can use less than, and we can use less than or equal, and all these are going to work, and this is really cool. So we can try and build this program. We're going to build with GCC, we can do that. The build is going to be good, and we can clear and bring up a PowerShell window that we can use here. And if we run Rooster, we should see our program running and saying the information that we need. So we're going to see that 0.1 is not greater than 0.2. This is going to be false. 0.1 greater or equal to 0.2. This is false. 0.1 equals to 0.2, this is going to be false. 0.1 is not equal to 0.2, this is true. 0.1 is less than 0.2, this is going to be true because the length for 0.1 is less than the length for 0.2, so this is going to be true here. And 0.1 less or equal to 0.2, this is also going to be true. You can try putting in different values in our point, and you're going to see that the relationships here are going to hold true. Our operators are working right, and the compiler is using these two operators to give us all the 6 comparison operators, and this is really cool. But this is not all. This is also going to support implicit conversions in either direction. Let's go down and put in a piece of code to play with us. Okay, so we are going to put in code like this, which is going to be comparing 0.1 with a literal of 20.1. In the second statement here, we're going to flip things out and say 20.1 greater than 0.1 and put a literal in the first position. And we're going to put this in our output statement here. We can copy this because I don't want to type all this. I am this lazy. And if we do this, we're going to see that this is going to work. Let's go back to our class and see if we have a constructor that takes one parameter, and we have it. This is really cool. So we can go back in our main CPP file and see that implicit conversions are going to work even if our three-way comparison operator is done as a member function. If you remember, in old C++ days, we didn't support implicit conversions for the first operand if our operator, or if our binary operator to be exact, was done as a member function. But in C++20, this is going to work because the compiler is going to flip things around and find an arrangement that is going to make the current logical statement that we are trying to evaluate work. And again, the rewrite rules are what we have seen before. For the equals operator, we are going to use this rewrite rule. We can rewrite A equals B as B equals A. We can rewrite A not equals B as not A equals B, or as not B equals A, and we can really reuse all these rewrite rules. If we come back to our code, what this is going to do, the compiler is basically going to do something like, let's do that below here. The compiler is going to flip things around, so it is going to say 0.1 and say three-way comparison operator, and it's going to compare this to 20.1, and it is going to flip the sign because we just flipped the operands, and it is going to say less than 0. And this is going to give us the relationship that we want. So let's build and run this. I am going to show you what we get by putting in this statement here, and we are going to replace in this thing that the compiler is going to be using behind the scenes. The compiler might not do this exactly, but this is a possible case for what the compiler might do behind the scenes to evaluate or process this statement here and give us an answer about this relationship that we are trying to evaluate here. Let's build and see what we get. We're going to use GCC for that. The build is going to be good. We can clear and run rooster. And we're going to see 0.1 greater than point with 20.1. That's going to be false because 0.1 has 10, 10, and so the point with 20 must be greater, and 20 greater than 0.1, this is going to be true, because if we pass it 20, the compiler is going to flip things around and use this relationship that we have here. So what I am going to do, I am going to comment this out, and I am going to copy this stdc out statement. I am going to put this below what we had before, and I am going to copy my thing here. I think I can do something like this, and I am going to copy it all, and I am going to replace that in here to show how the compiler might use our three-way comparison operator to evaluate what we have on top here, and we're going to get the same answer. Notice that we got a false and a true before when we were using this statement here. And let's build again with our new thing that we think that the compiler might use behind the scenes. The build is going to be good. We can clear and run rooster, and I will get a false and a true. And 0.1 is not greater than a point with 20's 0.1 n. And 21 greater than 0.1, that's going to be true. And this is really cool. This is working, and this is what the compiler might use behind the scenes to evaluate this relationship here. Hopefully this proves that the compiler is going to be using the three-way comparison operator to evaluate the relationships that we do in our code using the regular greater than and less than operators. And this is really cool. This is really all I had to share in this lecture, showing you how you can set up your own custom three-way comparison operator. One thing to know is that if you set up your own like this, which is not defaulted, the compiler is not going to give you a free equals operator. You will need to put that in yourself. Once you have these two in, you will be able to use all the 6 comparison operators. And this is going to be really cool. This is even going to support implicit conversions from all sides, because the compiler is going to do its best and rewrite your statements in an arrangement that is going to allow it to call the operators that we have done as member functions here. We are going to stop here in this lecture. In the next one, we're going to see how the three-way comparison operator and the equals operator in C++20 simplify the work we have to do to support logical operators for our own C++ types. Go ahead and finish up here and meet me there.